Good morning, everyone. Hello, welcome. So good morning from Tucson, Arizona. My name is Angel, staff developer advocate here at n8n. I am joined by Mary here, Mary Newhauser. Mary, well, welcome. Pleasure to have you on the show. How are you doing today?
Good, good. How are you, Angel?
Doing well, doing well. Super excited to have you on. Super excited for today's episode. So I had a chance last week to meet with Mary in person, and we got a chance to record an awesome demo for you all today. So today we're going to be talking about RAG. And before we dive into it, Mary, can you tell us a little bit about kind of yourself and how you got into RAG? And kind of, I think we met through our partnership through Weaviate. Can you tell me a little bit more about your background and kind of how we ended up here together?
Yeah, sure. For the last year or so, I was working at Weaviate on the developer growth team as a machine learning engineer, doing lots of stuff on RAG, vector databases, agentic RAG, you name it. And over the summer, I was working on a project for Weaviate, integrating the Weaviate vector store node. And yeah, that's how we met. And that was my first time actually using n8n. And it took a little bit, but then once I got the hang of it, it was pretty simple.
Yeah, it really is. That's awesome. Very cool. So you have a lot of experience then working kind of on the back end, basically kind of building out these vector stores that give these AI agents almost like a new brain, like a separate intelligence in a way, to help reduce these hallucinations that we see, right? Like, and to kind of get more contextually aware answers. So without further ado, we're going to dive into the demo that Mary and I recorded. Mary and I are going to be available in the chat to answer questions as we go along. And at the end, we're going to open it up to some Q&A. So if you have any questions or anything, feel free to either drop it in the chat or save it till the end, and we'll be happy to kind of address those as we go. So without further ado, let's jump right into it. Mary, thank you. Let's do it, and I'll catch you on the chat. Here we go.
Sounds good.
We're here today at the n8n office with Mary. A pleasure to have you here. We're going to be diving in today. You've prepared a presentation for us on optimizing RAG and n8n. I'm going to let you take over. If you want to start by explaining to those who may not know, like, what is RAG? Like, giving us a bird's eye view. So I'll let you lead.
Yeah, so RAG stands for Retrieval-Augmented Generation. And you might be wondering, what does that mean? Retrieval-Augmented Generation, if we step back a little bit, right when LLMs came out, we saw one of the huge first limitations of them was that they didn't have access to real-time data. Another significant limitation of LLMs is that they hallucinate. And hallucinate, again, means that it's giving the wrong answer, but in a very confident way. And so RAG is a direct response to these limitations. And essentially what it is, it's a framework that gives a large language model access to an external knowledge base so that it can ground its answers in the correct context.
Makes sense.
And essentially, you can recognize RAG like in just a regular chatbot. If you see this link here and it says, it gives it a link and it's citing its source. So basically when an LLM cites its source, RAG is happening under the hood.
Perfect.
And so when should you use it? Basically when you want to run an LLM or an entire knowledge base. And knowledge base, this can be a little bit subjective, but say if you just have 10 medium or smaller size documents, maybe even 20, those can still probably fit into what's called the context window of an LLM. So basically those can probably still fit into the prompt. Probably don't need RAG. But when you do need RAG is when you have a comprehensive data set of internal knowledge, privileged knowledge that you want the LLM to specifically use in its answers. Also, when you should use RAG when you don't want hallucinations.
Yeah, absolutely. Makes
Yeah,
total sense.
exactly. And another reason that you can use RAG is if you don't want to send privileged data to an API. And so in n8n, you can do this by using Ollama and running those models locally without sending it to the Google Gemini API or OpenAI's API.
Real quick, would it make sense then, I think, when building out one of these RAG agents, then knowing first what model you're going to be using, so whether it's Ollama local or OpenAI, if you're doing it remote, or one of the other Anthropic ones, not only knowing your model, but understanding the size of the context window. So you can decide going into any project that you're working with whether or not RAG makes sense in that particular, because there's variables here that you have to mesh, right? You're not just choosing an AI agent, you're also choosing the limitations of that AI agent. So you have to know them in advance. One of those being context window, right?
Definitely, and you should know the context window of the model that you're using. I'm a little bearish on context windows because basically the people that train these LLMs, they say, hey, we have a 32,000 token context window, but then when you run this test called needle in a haystack test where you're asking the model to basically retrieve this little fact that you've stuffed into a huge prompt, they don't tend to do that well. And so when a model says that they have a context window larger than maybe 8,000 tokens, me personally, I'm a little skeptical of that.
Interesting. Okay, cool. One of the projects we worked on internally here at n8n, that was one of the things we had to do, and it's how I discovered like how big like OpenAI's context window is. I found the tools to like take example input to see how many tokens they take so you can compare. So doing that kind of research first is probably like the first step in this RAG journey, right?
Yeah, and then comparing that, like comparing the size of those context windows to the size of your documents as well. Because that's the other thing. If you just have 100 short tweets that you want to feed in, you probably don't need RAG for that. You can probably use an agent. But if you have 100 peer-reviewed articles that are 10 to 15, 20 pages each, you're going to want to use RAG.
Makes total sense.
Yeah. So how does RAG work? It has two main stages. The first stage here is indexing, and this is where you are preparing your vector database to perform RAG. And so basically what you're doing is you are taking all of your documents, you're breaking up the text in those documents into chunks, which we'll talk about a little bit later with chunking strategies. Cool. You're sending those to an embedding model, and then the output of that are embeddings. They're also called vectors. And this is basically just a bunch of numbers. So sometimes that can be 768 numbers, sometimes more, sometimes less. But basically what it does is it's translating it from raw text to numbers that store the semantic meaning of the document itself. And then what you're doing is you're storing those vectors or those embeddings in your vector database, which can also be called a vector store. So that's the first stage. The second stage is what's called inference. And this is when you are writing a query and you're getting a response.
This is what most people's interaction with it.
Exactly. And so what you're seeing, what we see is here, just the query and the response. And then this over here, this is everything that's happening under the hood with RAG. And basically what's happening is you have a query. That query is getting sent to the same exact embedding model that embedded all of your documents before.
Got it.
It's generating those embeddings for the query. And then here, it is using vector search. Okay, so the second stage of RAG is what's called inference. And what you generally see is just a query and a response. All this stuff over here, this is everything that's happening under the hood with RAG.
Yeah.
And so what happens is a query is taken, it's fed to an embedding model here, the same embedding model that embedded all of our documents. It's generating embeddings for that query, and then it's performing a vector search. And this is essentially a similarity search. So what it's doing is it's taking these embeddings here, and it is searching the vector database, these embeddings that are in the vector database, and it's calculating the similarity between the query and everything that's in the database.
Would it be safe to say that like what you're looking for, as a form of an analogy, is like you're looking at the distance between the numbers that are represented in the embedding model and looking for the ones that are the shortest distance from the words that you're passing in your query?
Yes.
Okay.
Yeah, exactly. So all of these things are embedded in what's called the latent space. And it's this huge multi-dimensional space. You can sometimes visualize it in 2D or 3D, but essentially it's finding the query, say the query is here, and then it's retrieving several different objects, and it's saying, okay, what is the least amount of distance? And then I'm going to pick those, or I'm going to pick the ones that are the 5 most closest in distance to my query embedding.
And that's not going to answer the question, but those are just going to be returned. And just to make sure I understand here, these are going to be returned back to the context window.
Yep.
Now you have a new augmented prompt that includes the original query along with the results of the vector search, which then generate the final LLM response back to the user.
Yes, exactly.
Okay.
And so what in the response is that the response is grounded in this context. And usually what it's doing as well is you can even get it to cite like the chunk of text that it retrieved from the database. Yeah, so actually I didn't really know that there were limitations to RAG until I started doing it, because you think if the LLM is citing its source every time, it can't be wrong.
Right.
You think, oh, okay, so if it's using RAG, if it's being grounded in context, then it can't hallucinate.
Right.
But that's not necessarily true. And the biggest error here that happens is, generally speaking, when the wrong context is retrieved. There are other types of errors as well, but when the wrong context is retrieved from the vector database, it can lead to irrelevant responses. So maybe it's not answering the question that you asked.
Yep.
It can lead to incorrect responses. So the answer is just straight up wrong because, say, it took the wrong chunk or it took the wrong context.
Because it contained maybe a keyword
Yep.
that was included in that query. Contextually doesn't make sense, but it's applying it in a place that it thinks it does.
Yeah, exactly. And also sometimes responses can miss critical information as well. So yeah, it's only answering part of the question, and a lot of times that happens because the context has somehow been destroyed in that sense, which I'll talk about in a minute. And then another one is that the right answer can be in the vector database, but it's not being retrieved when you're performing RAG.
I think I've seen this before. So like one of the ways that I struggled with this in some of the builds that I've done is password reset or password management. Like you might get back, somebody might use, hey, can I reset my password? Or they might use something like, I can't log in. So it might pass into the embeddings vector search login info as opposed to password reset. And so it might miss one or the other.
Exactly. So those two chunks might have different embeddings and not necessarily know that they're related.
So to fix that, what you could do is like embed in like maybe the system prompt something that connects the two together. If a user is asking for their login information, make sure to also look up password reset information. So you include that vector query in the system prompt so it knows to then basically broaden its search based on the user input. You kind of have to almost know what the user is going to pass in as their query sometimes, right?
You could, but that's where chunking techniques come in, which I'll talk about in a minute. And those chunking techniques are meant to minimize the loss of context when you're breaking up your text for embeddings.
Okay.
So yeah, if you just look here at this example, you can see somebody's asking, what's the new remote work policy for Q3? So it's going to the embedding model, you're generating the embeddings, you're doing the vector search. So by retrieved context, these are the 3 retrieved chunks, the top 3 most semantically similar to the query. But you can see here, okay, remote access for laptops is remote access. Okay, that's not remote work policy. You can see why it might have been retrieved, but because it has remote in here, but it's incorrect. The next one, remote work policy for Q2 is as follows. This one is even more close, even more similar, but Q2 is not the same as Q3. So you can see here that there's the only difference between an incorrect answer and a correct answer is literally just a single digit. And sometimes that kind of nuance can be lost, but it's still wrong.
It's still wrong. And I assume that the only way that it could know whether it's right or not is now, instead of going into the embedding model, we have to go back into the training model that generated the AI to begin with. If this kind of connection as to what Q3 or Q2 even is, like that contextual awareness, like that has to be baked into the training data set, which is like completely outside of even the RAG side. Am I understanding that correctly?
Not necessarily, but what's interesting here is like Q2 and Q3. So if you're using an embedding model that's really general, it might not pick up on those types of differences. And so this important difference here may not really be visible in the embeddings. However, say you're using a fine-tuned embedding model that's specialized for things related to like business talk or stuff like that, then it might pick up on the difference between these two.
I think just to build on what you're saying, it's like your organization might have internal acronyms that you use.
Totally.
A tuned model would be tuned on those acronyms and understand what those acronyms are.
Yeah.
A normal like trained model is just going to have whatever maybe your dictionary has, or is on Wikipedia or things like that.
Exactly.
Right?
Whatever it was trained on, which is like the internet.
Yeah.
Yeah. So that's a great point.
Cool.
And then you can see here our company culture encourages remote. Yeah. Exactly. So it might go on to say we encourage remote work, and as of Q2 we are doing this, or starting in Q3 this is our remote work policy, but it's not giving you the whole answer.
Understood.
And so the problem is that when you're feeding the wrong context to the LLM, you're getting the incorrect response. And in a lot of ways it's almost worse than just a pure hallucination. Because you're thinking, oh, it's citing its sources, so this must be accurate. Exactly. It's very confident. And so we already touched on this, like why can retrieval fail? And a lot of times it's because the context is lost during the indexing process. Whether that's during chunking, whether we said like internal acronyms that the embedding model just doesn't really understand that. There's a lot of different ways it can happen. Another thing is like too much or too little context is being retrieved. So this is why you want to play around like with your chunk sizing. So if your chunks are way too small, you're not getting the bigger picture and it's going to miss a lot of information. If your chunks are way too big, then it's too much information that's coming back. So it's really...
a needle in the haystack kind of issue.
Exactly. It's really a delicate balancing act.
Which then I think goes back to two things. Understanding again your model. What model are you working on?
Yep.
What was it trained on? You may not have an exact understanding of what the training was, but at least have a basic understanding. And then on top of that, on the RAG part specifically, you need to have a very firm understanding of what it is you're building on top of, what language is being used, and not just like English or whatever cultural language. Is this an organizational language? Are we using specific industry terms for a standard organization? Things like that. Are these things we need to provide as part of our vector embedding and chunking? Or is this something that already is part of the original training data set? We don't need to worry. Like those are things we should probably be thinking about as we're building this stuff, right?
Yeah, definitely. And like that actually fits in perfectly with this point here, is that sometimes the embedding model isn't capturing the meaning. And so with RAG, you're using different models. You're using a generative model, so something like ChatGPT or Google Gemini that's generating the response at the end. But then you're also using an embedding model, which is a different type of model. It's not a generative model. And embedding models are trained on, generally speaking, task-specific data sets, so like trained for retrieval, but also domain-specific data sets.
Understood.
So for instance, if you want to do RAG over medical documents, probably using whatever text embedding O3 generic model from OpenAI for embedding, that's probably not going to give you the level of detail that you're looking for.
Absolutely. Makes sense.
And then the last thing,
Oof.
which, yeah, you don't think about this unless you're like wading
great.
deep into the data, is that sometimes the data set contains conflicting information. So, here you might have something there might also be there might be like a Q3 remote work policy version 1, and then version 2, which is like the revised one, because maybe they said you have to come back into the office.
Oh no.
And then everybody was like, we're going to quit. So they're like, okay, V2, you guys can stay remote.
Makes total sense.
Yeah. And like with the limitations of RAG, you want to keep these in mind. And the good thing is that there's so many different ways to optimize RAG, specifically targeting each of these problems that we talked about. And actually, there's a lot of ways to optimize RAG in n8n, obviously, like without any coding, which is great. And that's what we're going to go over today as well. And so you can see here that like each of these green boxes represents a different stage in the RAG process where we can apply these optimizations in n8n.
Makes sense.
And so what we're going to do is we're going to go over chunking strategies, which are probably might be the most important.
And I know we haven't really talked much yet about chunking. I know we're going to dive into it much deeper here in a second. Needless to say, it's just a way of separating, indexing data, right? Splitting it up in a way that's easier for the system to search.
Right. Because you don't want to embed an entire document and then when when your response is coming back from the LLM, it's giving you, this entire document rather than just the answer to your question.
So it's almost like we're giving it snapshots of the information so that when it retrieves the information you want, you give it back a predetermined snapshot of the whole context of that information. So this goes back to what you were saying earlier. If you don't chunk it correctly, you might get the end where it has the word, but not the beginning where it has the context of how to resolve what you're trying to do.
Exactly.
Makes total sense. I'm with you.
Yeah. So chunking strategies, also going to go over leveraging metadata, which can really improve the accuracy of retrieved results. We'll talk about embedding model selection, prompt engineering, and finally re-ranking.
Awesome.
How to implement RAG in n8n. First of all, thankfully, this slide is super easy because it's just easy to do in n8n. Basically, what you have here on the left is this first stage that we talked about. So this here is the inference stage. And this is RAG in its most simple form, where you are uploading your data, you're generating embeddings with an embedding model and inserting that into a vector store or a vector database. And then this default data loader, this is where you tell n8n which column or which field you want to generate embeddings for. You can specify metadata, etc. And then the second part, connecting the AI agent node to your vector store using the same embedding model. This is the inference stage. So pretty simple.
Yeah.
And so let's get going into chunking strategies. The first one and the easiest one is called fixed size chunking. And basically it is what it says it is.
Yeah.
You determine how many tokens you want in each chunk, and it basically cuts that up blindly.
Beautiful. I love this visualization. I love the overlap because this kind of goes back to what we were just talking a moment ago about how you need this overlap because what you're really doing is creating snapshots. So the embeddings is really your knowledge base split up into different chunks.
Yep, and the overlap is essentially, it's a way to preserve context that is being cut up so that it's not completely lost.
Makes total sense, yeah.
Yeah. And over here on the right, this is how you do it in n8n. Basically, you see this character text splitter node, and here you can determine the chunk size and the chunk overlap. Looks pretty simple.
Makes sense. I've done this before as well in one of my other videos, and I found the process to be very simple and straightforward. Like even with the way the n8n has it laid out, it's very straightforward.
And like the nice thing about fixed size chunking is that it's super easy.
Yeah.
It's simple, it's cost effective. The overlapping can help with lost contextual awareness, but the cons, and honestly, I wouldn't recommend using this as a final chunking strategy.
Okay, yeah.
It's nice if you want to make sure that you're uploading all of your data properly and you want to be checking things and stuff like that, or it's just a proof of concept, you don't want to deal with it. For that, this is great. But yeah, the cons are that it does lack contextual awareness. And if you say you want the chunk size to be 10, maybe the most important word or token in the whole sentence is word 11, it's going to get lost.
Absolutely. That makes total sense. So this might be like a good starting scenario as somebody who's starting down this journey of embedding their documents and their knowledge base into a vector store. This might be a good way to start testing things, to quickly get the data chunked and embedded so you can jump right into kind of the RAG kind of inference stage. Right?
Exactly. And it's also nice too if you want to play around with chunk sizes. Here I just put 1,000. That's probably too much.
Yeah.
But you can also
and 1,000 what? That's 1,000 tokens, which is 3 or 4 letters. It's not quite a word, but it's like a partial word, more or less.
Let's just count it as a word.
Okay, perfect. I think that does simplify it a bit.
Yeah,
Not
exactly.
quite a word, but almost a word.
Almost a word, yeah. And so the next strategy is called recursive chunking. And what this does is it's breaking down documents hierarchically on separators. And by separators, things like periods, comma, punctuation, sometimes even spaces, semicolons, whatever. And this is a much smarter alternative to fixed size chunking, and it preserves more context. This is also a pretty good chunking strategy for shorter pieces of text. So say social media posts, Slack messages, comments, reviews for e-commerce data, stuff like that, or other pretty unstructured text.
Makes sense, yeah.
Yeah.
Love it.
And so in n8n, you use the recursive character text splitter.
Interesting.
And then it's just the same parameters as before, chunk size, chunk overlap, pretty easy. And yeah, like I said, this maintains more of the semantic context because obviously if you were to chop this up here,
you would lose part of the context. This is what you were talking about earlier in destroying context. I don't think I fully understood that until now in terms that like your chunking strategy could accidentally destroy your context if you're not careful. And this is such a great way to do it. So the other thing is that I think I've seen this one before. I've never used the recursive character. I think I was just scared of it just because of what it was called. I didn't fully understand the word recursive. Now that you explain it, it makes so much sense. Yeah. But without fully understanding it, it was just a little intimidating. That's great.
Yeah, if you think you're going to mess something up, actually this is probably going to make it better.
Yeah. A
con is that, again, the chunks can be too big or too small. If, say, you're splitting on commas, you're going to be breaking up sentences. And maybe that's not something that you totally want to do. Or say you are splitting on periods and you're breaking things up by sentences. Sometimes an idea in the second sentence is helping explain something in the first sentence. So you can see why you're still making a cut somewhere, so you're still going to be losing some sort of context.
Makes sense.
And that leads to the third chunking strategy available in n8n, which is my favorite and the one that I would personally use and recommend the most. And this is document-based chunking. And this is great because the chunks really respect the natural divisions in a document in a better way than it does with recursive chunking. So you can see here that you have this is markdown. Here you have a heading. This is part of the heading. You have a subheading, etc., etc. And this is great, especially for structured documents. So you can see here, like a markdown is a very structured type of document.
My favorite.
Another structured document would be like a scientific article or like a scholarly article that has a title, an abstract, an introduction, something that's citing its sources.
A web page,
blog posts, stuff like that. Really all types of different documents.
Let me ask you this. Would you consider a JSON object a document? If you had multiple JSON objects, they were maybe each were less under 1,000 tokens, Would you consider maybe that being each one of those JSON objects be the document? Or would that be, or are we talking actually, we're talking if the JSON object is like a string in markdown format, then that would be it, right? Like it's that markdown format that is really doing the chunking here. It's the standard in which the text is stored, really, right?
I would say in this case, so here what you can see is right now we're splitting the code on Markdown. In n8n, you can click this button, and what's going to pop down is a whole bunch of different options.
I see.
And so another option is probably, I think it's going to be HTML. Another option might be JSON. And then this also works for different programming languages. So I know for sure that you can split code based on Python programming language. So really what you're doing, like you're choosing here in this split code section, you're directing the chunker how to chunk based on the type of document.
Makes sense.
That it is. And so this is great because it preserves as much context as it can, like within n8n by using these chunkers. And it's really nice because it accommodates various document types. Like I said, Markdown, HTML, even LaTeX, that's the mathematical statistical language. And like I said as well, it's ideal for structured documents, but also it struggles with large documents.
That answers the question I was about to ask.
Yeah, because the problem is the same no matter what. You're making a cut somewhere. And wherever you're making that cut, you risk making it at the wrong
Losing
place.
that context.
It struggles with large documents and also large chunks can introduce noise.
Yeah.
So when basically it's returning a response and you have to wade through the response for the answer when I just want the answer direct. The reason I'm using RAG is because I want you to tell me the answer, not so that I have to go back into the text and find it on my own.
Yes.
It's also less ideal for unstructured documents.
Makes sense.
Yeah. And so next is leveraging metadata. And essentially metadata is, so what you're doing when you're embedding data into a vector database is you're taking usually one field, which say it's like the text field. So this is the text that you want to embed and you're generating embeddings for that. So let's say for an e-commerce example, this is a product description, embeddings for the description. But then you also have this supporting data that goes along with it. You have things like you have a column for the price. You have a column if it's clothes for the size, stuff like that. Maybe there's a category that it belongs to. This is what's called metadata, and it's all helpful. It's helpful to use for both filtering and for enrichment for the data because it provides additional context. And providing additional context is always a good idea. Yeah. And so using metadata filtering is a really easy way to improve retrieval accuracy. And you can see here in this visual, so say find women's cowboy boots for less than $100. So say it does a vector search and it returns these top K results.
So we talked already how those are generated.
Exactly.
So now we're adding a new layer to this.
And so these are derived semantically.
Understood,
So in the latent space, these are the closest results to this query.
This is about similarity, semantics, whereas metadata is about like a hard binary, true or false. Does this meet this condition or not?
And so here we have a metadata filter. So we say, okay, now after the vector search has been done, do an additional filter on this metadata and now only return the ones that are less than $100. And so then you're ending up with something that is ultimately much more accurate.
Understood.
And this is an easy lift too. It doesn't require that you need to regenerate embeddings. It doesn't require any API calls, any AI, anything like that.
And I have a question. This makes so much sense. And I'm just like wondering how much additional work is required for this filtering? Is this just a natural aspect of part of this vector-based searching process where the training of the model determines whether or not it'll automatically apply this type of metadata? So what I'm imagining is, okay, I'm going to give an AI a vector store. Here you go. That vector store you can search. I'm assuming that the filter exists almost like as a column, right? It's like you have available this pricing column, right? And so the AI can see it has a search capability and almost like a column capability, and it knows that it can pass into it both, or is there something, an additional step you have to do to enable it to filter more effectively? Is the filtering automatic? Is it just a part of its own training, or is it something that you need to encourage somehow as part of your prompting?
So it has nothing to do with training because we're not training a model here. But what it does require is that you need to specify your metadata in n8n before you send it to the vector database.
So this makes a lot of sense. So we've got our filter in place. That is giving us our final results. These results are not the final results in terms of what is output by the model, but it is used to create the final inference output, correct? These two like final results. So the filtering process happens before the answer is generated. It's just passing in less items so you have more context in those less items.
Exactly.
Cool.
Yeah.
All right, excellent.
And so what you need to, basically, you can't just assume that your metadata is going to be inferred when you're generating your embeddings. You have to specify it.
Okay.
And that's where you do it here in this default data loader. And so in this instance, we're embedding the metadata, or no, we're not embedding the metadata, we're including the metadata. And what you do here, so here, metadata, here we have, this is, in this example, an archive ID, so this actually defaults to like the title of an article, like of a scientific article. And then you're putting in here, you're saying which field that is in the JSON, and you're saying, okay, this is metadata, this is the name of it, and this is where it is. And this is what you need to specify before you generate your embeddings.
Love it. Makes sense.
Yes. Next is embedding model selection. And so you really want to make sure you're choosing a model that makes sense for your specific use case. And a good embedding model, like we talked about before, it can understand the nuance in very domain-specific text. So it's like that difference between Q2 and Q3, or sometimes understanding acronyms or just treating them as random letters. And so embedding models, it's their job basically to translate this raw text into these numeric vectors or embeddings that capture the meaning of what it is. And so you can see here, so these are some kind of technical terms. So here you have pull request, people who are active on GitHub know what this is. You have a patch, bug, and insect. And so this is where the context part comes in.
I see it, yep.
And so here for these are each of the embeddings. Basically this here is sent to an embedding model. The embeddings are here. And then if we can perform dimensionality reduction and we can somewhat visualize these embeddings in the semantic space. And if we used an embedding model that was trained on, say, GitHub data or very specific...
Or insect data.
Or insect data, yeah.
Depending on which one.
Probably GitHub data, because it's saying here, it's noticing that pull request is similar to a patch, which is like a fix, which is similar to a bug, but then it's saying that bug is totally different from insects. But say, and this is just a very basic example, probably.
And this is specific to this embedding. Because like in a different embedding, bug might actually be right next to insect because it's a database of bugs. Right?
Exactly.
As opposed to like code bugs.
Yeah. And so this just demonstrates the fact that you want to make sure that you're using a model that makes sense.
Yes.
And generally, I'd say for me, if it's a pretty general type of text, like everyday language, not a lot of special or hidden meanings, maybe if like very fine details are not super important, it's just the bigger picture thing, generic embedding models are just fine. And probably you might even want to start with them. But if you're doing RAG over legal data, medical data, financial data, you're doing it over a code, like
complex
a code
domains.
base, something like that.
Very acronym heavy.
You're definitely going to want to use an embedding model that was trained on understanding that type of language because they understand the nuance. And so when you're choosing an embedding model, you really want to consider context length. So just like generative LLMs, embedding models have context windows as well. So sometimes sometimes an embedding model will only take the first 2,000 tokens in a text, and the rest it can't receive. So that's something you want to think about. The domain that the model is trained on, like I said, medical, financial, legal, and then you also want to keep in mind the overall performance of the model. And you can actually check that out on the Hugging Face, massive text.
I was about to ask you what that MTEV was, but now that makes sense. Hugging Face, yeah.
Yeah, and so that's a really easy way to see how specific embedding models perform on different tasks, how good they are for retrieval, re-ranking, etc. In n8n, you can select your own embedding model. And so basically what you do is when you're adding a new node, you just want to search for embeddings. And then this is going to give you all the options that you have here. I would say for me, I just default to OpenAI. I don't know why. Maybe it's like the first API key I ever had, but I always tend to default to it. There's probably there are for sure better models out there, but they have a pretty good like general purpose like workhorse model that's usually pretty good, at least for experimenting.
But I want to thank you, Mary, because like before today, I also would default to OpenAI, but it wasn't until today and to this kind of slide that I really understood the importance of knowing the difference, understanding kind of the back end of this part of the particular model system.
Yeah, and I would say as well, like open source embedding models are just becoming better and better and better. And you can see here embeddings with the Hugging Face inference. This would be a great option, say, if you wanted to use like an embedding model specifically for like medical data. So you could even look up here. You could look on the hub, the Hugging Face model hub for an embedding model that does that, works in that domain. You can look at the performance and how it is relative to other models in the space. And then using the Hugging Face embeddings inference, you can easily, easily use it in n8n. And then another cool option always is if you want to do things locally, just use Ollama.
For the nerds in our audience.
Yeah, and so I would say here that this is probably like one of the hidden gems in n8n, the fact that you can use so many different types of embedding models. And it's probably one thing that people didn't realize, even like you and I, like we say, we're just using OpenAI for everything. But this here is really valuable.
Awesome.
And then we can get to prompt engineering, which it wouldn't be a presentation on AI if we didn't talk about it. And to be honest, like I thought that prompt engineering was just going to be dead. I thought it was like a dying skill as these models got better. But now that we're using agent, we're finding that prompting is more important than ever.
I agree. Yeah.
And so like in regards to n8n, when we talk about prompt engineering with the AI agent node, there are actually 3 really important fields that we want to pay attention to. I'm going to show you that here. So first we have the user message, and this is very brief. This is short. It's just a succinct, brief instruction, and it has direct input from the end user. And in the case of RAG, that's generally just going to be like this chat input here. So this is just going to be the query. And then you have the system message. Now, this is pretty important, and I think it's even optional that you don't even have to add a system message. And so for a while I wasn't, and then I did, and for me that made a huge difference.
Same.
And so this here, it's really a set of very detailed, precise instructions. It needs to include context. So I always tell it like, okay, your job is to perform retrieval. This is the data set that you are being given. These are the different fields of metadata that are being given. Everything like that. Everything you would want an agent to know. And I would veer on the side of being more descriptive here rather than less descriptive. And so this should for sure include like query instructions, explanation of the metadata schema, like I just said, reasoning instructions. If you want the agent to be doing any type of analysis on what you've been retrieving, and the specified output format. This is pretty important too. If you're just doing if it's just a chatbot, then the output format is not so important. But if you're doing something like with the workflow that I'll demonstrate, where basically the response from RAG is being sent in an email, you need that to be in a very specific format.
Makes sense, yeah.
And then something I always choose to include is an example of real output as well. And then sometimes even a description of that output and why this is a correct response.
Could I add one thing to that list?
Yeah.
I might also include an example of what no output would look like. Especially for structured outputs when you're doing like big JSON objects, including something like, this is the expected output if values are found. This is the expected output if no values are found.
Yes, and this is a great point because sometimes we forget to tell the AI, don't answer the question. Don't make up.
Yes. Don't lie, please.
Yeah, don't lie. Like, that's why we're using RAG.
I know.
Yeah, exactly. If you do not, if no answer exists, specifically, no answer exists.
Yes.
Yeah, that is a great point.
It's almost like, I almost feel like if it had a personality, it'd be like scared to tell you the answer and you have to coax it. No, it's okay. You can tell me the truth. It's okay. I won't hurt you. So, totally get it. One other thing, system message, the way I think of that is it's personality. Like you're saying the prompt user messages, here's the what you need to work on. And this system message is this is who you are.
Yeah, and how I want you to do it.
Yes, exactly. So it gives it its purpose too. So I love it. If you're going to anthropomorphize AI agents, that's how I do it.
Totally. Yeah,
Perfect.
Just some arrows.
No, that's great. Makes sense.
Okay, this one is actually really important and I learned it through trial and error. And so this is the vector store tool description and I'm going to show it here.
Nice.
So here we're using the Weaviate vector store node. And what we have here is description. And what I was doing, you also need to make sure that you're choosing operation mode, retrieve documents as tool for AI agent, of course. But this description here, it instructs the agent how to use a tool and to use the tool, because just because you attach a tool to an agent, you cannot assume that the agent is going to use it. You need to give the agent explicit instructions to use that tool, and you need to tell them how. And when you're doing RAG, this is always in the vector store node, which is a key detail. This here is the AI agent node. So it's important to know that this is in the vector store node. And a good tool description always includes what the tool does, obviously, when the tool should be used, maybe when it shouldn't be used as well,
of course,
going off our previous conversation, how the tool should be used.
I'm with you so far. This is making sense. I think that the way I see this as it's yet another puzzle piece in this whole AI thing, right? You have when you're building the description of the tool and things like that, you have to tie that description back to the expected user query in many ways. Almost have to preemptively know the language of the person who's going to be performing the initial query. So for example, an example I like to use for some of the tools that I'm using internally is we have an internal vector store for our competitor information, but the only way the tool description will trigger its use is if you use a query that's n8n versus insert name of competitor there. I know that's the language our team uses, so I built that into the description so it could catch those types of requests based on natural language. So in a similar kind of stance here, when we're creating these tools and these vector stores, we want to make sure that it knows what it is, and we have in the back of our heads have an idea of what types of queries are going to be entering in to make sure they kind of align with the tooling that we're giving it, right?
Yeah, definitely. And I think I struggled when I built my RAG agent in n8n. And basically what was happening, it was going through this whole huge workflow, and then every single response was hallucinating. And so when I looked back into the logs and I said, what's going on? It wasn't querying the vector store at all. So that's why it was hallucinating. But it wasn't super apparent to me. I just knew because I knew the content very well. So this is something you really want to make sure,
For sure.
that you're getting a good tool description in there.
Very cool.
Finally, we come to re-ranking your vector search results, and basically what this is, it's a different type of model coming in after the fact, after the context, after the results have been retrieved, and we're feeding in that data into a different type of model that is ranking these against each other.
Oh, how funny.
Yeah.
Interesting.
So you can see here, like the women's cowboy boots query, again, this is going through a vector search. We have 5 results here, all of varying relevance.
Yeah.
They go through a re-ranker model, and then it re-ranks them to this.
Wow.
And so this is really nice because, and you can use Cohere re-ranking models, and I think their pricing is pretty good as well. And it's all through an API. So it's not a model that you have to train. It's not a heavy lift. It's really easy, and it's a different type of model. It's a cross encoder. So basically what it's doing is like it's processing the query. It's feeding in this, and it's feeding in the results, and then giving a relevance score for each of these results.
That makes total sense. And I think that, I guess my question is twofold. Is this a conscious thing that we have to set in n8n?
Yes, it is. You have to add a node for it.
Perfect. And then in that case, like how many, is Cohere the only current option that you
Yes.
know of?
That I know of, yes.
Okay, cool. That answers the question. Perfect.
Yes, and that's actually
There
right
it is.
here.
Beautiful.
And yeah, you choose your model. And then top N, this is similar. So it's saying the top however many results you want to be returned.
I'm with you. Makes total sense. Wonderful. Wow. Mary,
Yeah,
this
maybe
has been incredible.
Yeah.
Thank you.
Wonderful. Well, thank you so much, Mary. I think we had quite a bit of interest. I was following the chat, and I think a lot of people were really interested in the talk, and we got a lot of great feedback. So if you have time, I'd love to. I know we have about 7 minutes left. We currently have about 21 questions in the queue. So I figured we'd dive into them.
Do we have any repeats?
Maybe. Let's take a look. So I'm going to share them on screen, and we'll just dive into them one at a time.
Cool.
So let me start at the beginning here. So the first one we got, any workplace enablement resources. So I have a team member that does focus on these types of resources. I just reached out. He's on Europe time, so I think he's just finishing up for the day. So I'm going to try to put them in the description of this YouTube video. Any that I find. Mary, do you happen to have any off the top of your head?
Like with n8n specifically?
Yeah, I mean, I guess n8n or AI based, resources. But
So there is an ebook that I worked on when I was part of Weaviate, and it's called the Advanced RAG Techniques ebook. And if you just search that, it's totally free. It has a lot of but this isn't specific to n8n or to Weaviate, really.
Yeah.
It's just, it goes over a lot of the techniques that we talked about here in more depth and has a lot of good visuals.
Love it. Cool. We'll try to link that on the description. Awesome. The next one that we're showing, let's take a look here. Do any of the chunking strategies have an impact on the cost related to your embeddings? I thought this one was really good. I mean, there is a cost because it is still like taking tokens in and out, right? Which is where the so I suppose I guess would be like, imagine if we fed in a raw document, and let's say that raw document was in Markdown, but you fed it in kind of raw, or you do it using, what is it, the recursive chunker, which we can break it down as a Markdown document. Would one or the other have a different cost, or would it be the same cost across both to embed?
So if you're using an API to generate your embeddings, I'm not totally sure. I'm not 100% certain on API pricing. I mean, it's the same number of tokens that are getting embedded. each
Yeah.
time. So my instinct is I want to say that no, it wouldn't have an impact on the cost, but it could have an impact on the cost of storage. So
Mm,
if you're using a vector database, like if you're using a paid option, or even if you're using something free locally hosted, if you
mhm.
have more chunks, you're going to have more embeddings. So the database is going to be fuller. So that there is probably a cost there.
Makes total sense. Yeah, makes total sense. Great answer. Next up, we have when the agent is connected with an Airtable database, is this a RAG? This is a great question. I think you know the answer, Mary, so I'll let you answer this.
Yes.
But I have my own.
So no, it's not. And I assume that if it's connected to an Airtable database, that or anything else that resembles data, a data table, anything like that, I would assume that information, that data is being fed into the LLM context window.
Mhm.
But as it's not RAG because you never generated embeddings for it with an embedding model.
Would a more accurate term for this, depending on like the use case, and I'm specifically talking about n8n, would we call this a tool instead? It's an agent tool, right? So if we're connecting an Airtable database to
Mm-hmm.
an AI agent, that in n8n's language, right? We
Right.
call those a tool, not a RAG. So it's like an AI
Yes.
agent that is tool enabled as opposed to RAG enabled, maybe.
Right. But there is no active retrieval that is going on there because there are no embeddings.
Correct.
And yeah, to compare to the query embedding.
Would a different way of verbalizing it be like semantic search versus something else, maybe? Or, anyway, yeah, I think that there's like a better way to word it, but I'm struggling to kind of come up with the right words or the right terms. But yeah, any ideas on your end before I move on to the next one, Mary?
Yeah, so I think that the distinction is basically that when when your documents haven't been embedded and stored in a vector store, then but it's still connected to external data,
Mhm.
like Airtable in this instance, all of that data is being inserted into the context window of
Mhm.
the LLM. So all of that data is going into the context window, whereas with RAG, what it's doing, what's getting put into the context window of the LLM is these chunked pieces that you have embedded in your vector DB.
Perfect. I love that distinction. All right. Well, excellent. Let's move it along here. Speaking of respecting the document structure, what is the big difference between recursive chunking and document-based chunking, given both respect the document structure? I think this is standards, right? It's what standard it's following to chunk as opposed to what it's chunking.
So document-based chunking, it's still using the recursive chunking node,
Mhm.
but what you're doing is there's an extra option where you can add the type of basically the type of document you have. Well, not necessarily document, but coding language.
Mm,
So this is where you can say you can specify and say, okay, this is in Markdown or this is in Python. Um, that's giving you that extra functionality there.
okay, makes sense. All right, moving along, we have, can a section of document be too big for RAG? And there was a follow up to this question because I had said kind of like this is kind of the point of chunking, right? If it's too big, we're chunking it up to break it into smaller pieces that can be brought up individually, right?
Yep.
Am I understanding that part correctly? I think what they were saying is like, let's say you have a markdown header, right? That header is extremely long for whatever reason. Maybe it's the size of a context window on accident. Who knows? Just for the sake of argument. Can that be too long to like be chunked up, basically?
Yes. So each embedding model also has its own context window.
Mhm.
So this is why choosing an embedding model, it's important to get it right, because say if you are just embedding, Slack messages or tweets or really short form content, you don't need an embedding model with a large token window.
Yeah.
However, if you are embedding like full documents that have lots and lots of tokens, you're going to want to look and see what the input limit is for
Mhm.
that embedding model, because at a certain point it will just cut off, and
Makes
it will create embeddings, but it will just cut off
Mhm.
at this token limit.
That'll
And
truncate.
that's dependent on your embedding model.
Makes total sense. Awesome. Great answer. Oh, here's the answer to the previous one, to one of the earlier ones. The next one is, where would you apply the filter on the embeddings? So I think this is a question I think I kind of asked you a little bit. It's like, for filtering, is that something you have to set in n8n, or is that like automatic as long as the metadata is defined?
So I'm not totally sure. It might vary depending on which vector store node you're using, like if you're using Weaviate or Quadrant or Pinecone. But what I do is, you have to make sure that you have the metadata has been stored in the vector database. That's step number one, and that happens during the inference stage. And then for me, what I do is I instruct the RAG agent in the inference stage, and I say in the prompt, I put the whole metadata schema and I explain what each of the metadata fields are. And
Mm,
then I specifically instruct the RAG agent to use that metadata in its filtering.
great answer. The next one I think might be a little bit outside of our purview here, but let's try. What are the limitations of this setup, simple RAG, to deploy at scale? For example, 1,000 requests an hour. Have you ever worked at this level of scale, Mary, in terms of like, are there any limitations we should know about? Like if you have like an entire enterprise organization, like slamming a vector store, did you ever see that at Weaviate? Like where, you know, I'm assuming like the vector store could handle only so many requests per minute or per hour. Did you see those types of limitations or issues?
So I never worked specifically on like kind of on the solutions end, like setting things up for customers or prospective customers. But I do know that Weaviate and other I believe other vector databases have what's called multi-tenancy,
Mm,
and that is intended to oversimplifying it here, but that's intended to help you scale.
I see. I
Yeah.
see. Awesome. All right. Excellent. Next up, this is a good one. Does the recursive text splitter turn the input from the document into Markdown, or do you provide the content in the Markdown format to start? If the latter, what's a good way to convert Microsoft and PDFs? So I have an answer that I got from one of our DevRels, but I'll let you start, Mary.
Yeah, so the recursive text splitter, that is not converting a document. That's not converting forms of document or formats of text in any way. And I think that you probably have a good answer for the second part of the question, right?
Yeah. So there's a lot of different ways that I think you could do this. Now, for Microsoft specifically, Jamie, one of our DevRels, he recommended a GitHub a repo called Markdown, which will convert Microsoft documents to Markdown. PDF, I think, is a little more difficult because you either have like PDFs with embedded text. Those are, a little bit easier because those can be extracted. The text won't be formatted very well in Markdown unless it was already in Markdown. Even then, it's going to introduce a lot of like PDF artifacts in there. So I would probably use like another LLM to clean up the formatting of those outputs into like a clean, structured Markdown. Especially, and even if it isn't in Markdown, maybe that could help convert it over. It might not be perfect, but it could do the job. And then if it's an image, you're going to have the additional step of converting the image via OCR to text, and then need to format it better to then get it into this. Right. Are there tools that you've heard of, Mary, that can like work specifically on PDF files or Microsoft Documents?
Yeah, this is actually a huge like subfield for RAG in general, because a lot of the world's data up until now is stored in PDFs
Yeah.
and isn't necessarily stored cleanly in a database. And so there's many different methods, a lot of them open source, some of them paid, that you can use to convert PDF to, say, something more structured like Markdown. I think that's generally the most common way of, or into JSON. So for instance, if you have a paper that's like abstract, title, authors, whatever, you could convert that either into Markdown based on those headings and stuff like that, or convert it into JSON. But my favorite one is actually, it's called Dockling, and it's an open source Python package that is maintained by IBM.
Oh, nice.
And I'm not sure how you would get that to play well with n8n, but I know if you know Python, that would be my recommended way of doing it. Oh,
Okay.
and also Mistral and Llama Index have paid services that you can use, I believe, for using LLMs to parse PDFs.
Makes sense. Makes sense. I'm just catching up on the actual chat here because I'm digging through all of our pin chats. Just want to make sure that I'm not.
People love Dockling. That's great.
Oh, good. I'm glad to hear it. I'm trying to make sure I'm not missing anything important in the main chat here. All right, let's move on to the next one. How can you embed images that are on a document? So I think this goes back to the PDF thing, right? Because I mean, some PDFs store text as an image almost, right? And then we're talking about images, right? Which might just be more abstract and not text-based. How would you?
So in RAG, I don't know about n8n specifically, but
Mhm.
if you want to embed, you definitely can embed images into a vector store. This is how a lot of like image search and similarity search works. Like if you have an iPhone and you just type in dog, and it returns all of the photos that it thinks has a dog in it. But what you need to be aware of is that you need a different type of embedding model to embed images. Most embedding models, like that we've been talking about, just handle text. So they take in the raw text and then convert it to a vector. But a multimodal model will take in an image and convert that image to a vector. And so that it's possible, it's super valuable, but it's definitely like a level up in terms of complexity for RAG.
Makes total sense. Yeah. I might have taken a totally different approach and then used like AI to convert the images to text, and then from there store the text. But I like the idea of preserving I feel like you're almost compressing an image by converting it to text. And if you want to keep the original fidelity, you need to keep that binary object instead. So I love that.
And like the images too might not have any text in them. You might want to be, like I said, you might want to be doing an image search. But likely those images will also have metadata, which we talked about, which you can store as well. I'm sure there's also options for even generating text descriptions of an image.
Yes.
And then using a multimodal model to generate embeddings for that text description, which is like data enrichment, and as well as the image itself.
Makes sense. All right, let's move on to the next one here. We've got, will you be getting into the relative merits of different vector stores? Now, I think just as a preface, Mary's a little biased because she did work at Weebly previously, but I love this idea. I wonder if, like, now that you're a free agent, Mary, is this something maybe one day me and you could talk about on our next at scale episode? Maybe some of the ones you've worked with or you've played with. So
yeah, for sure. I think Somebody commented on this in the chat about hybrid search and how hybrid search really improved retrieval, like for their RAG pipeline. And hybrid search is really like the cream of the crop. It just to oversimplify it, it basically it gives you the power of keyword search with semantic search. And as far as I know, I'm not sure that any vector database nodes in n8n natively support hybrid search. But if there were to be like a native vector store node that supported hybrid search, I would probably go ahead with recommending that one because it's just going to give you a lot better power at like limited cost.
Awesome. I love it. I love it. And somebody asked on the chat subtitles. Yeah, for the next one, I feel so silly. I had the option to put the subtitles and I didn't do it. The next one I will. I see the benefit now, everyone. So my apologies. All right, next question. Can a local database be connected to the n8n? This one's pretty straightforward. The answer is yes. Yeah, Mary knows. I'm sure you've done it many times, especially if you're running it locally, right? Like you're running a local instance of n8n. It's very easy to connect it, either in the back end via Docker or whatever it is you're using to deploy it. All right, next up, I think we're making progress here. We're way over, so I apologize to those. Thank you for everyone that's held on. I typically chop my streams like on the dot. I'm trying to extend a little bit more, get some of these questions answered rather. Oh, yep, somebody answered for this as well. In n8n, you can connect to a wide range. All right, let's take a look. I'm wondering, how does it differ when an agent does not use RAG versus a RAG agent? I thought this was an interesting question. So I think another way to phrase this is like, what's the difference between, having like a vector store attached to an agent versus putting everything in the context window? Is that a fair way to rephrase that, Mary, would you say?
So I would say the RAG node that I think is kind of the default for n8n users, I believe that is an AI agent node. And that's the AI agent node, and that is connected to your vector store, which is being used as a tool. And that AI agent node, it has extra capabilities. You can instruct it to do things like reformat the query, or maybe even do LLM as a judge for evaluating the retrieval. And it has these sort of self-optimizing traits, as opposed to just a regular RAG node, which when I was playing around with n8n, I thought that like the question answer node, some of the older nodes, that is more like pure RAG.
Makes sense. Makes sense. I see this next question. I thought it was a good one. How can a workflow identify when to use a RAG search versus the model answer the question? I think this is a great question. Go ahead, Mary. I have my answer ready.
I mean, the whole point of RAG is like you want the agent to do it. And I've had issues before where I was setting up like an AI agent node with a vector store, and it actually wasn't querying the vector store at all. And it was just totally hallucinating and giving like wildly poor false answers. And that's because I didn't put in the tool description of the AI agent node and the vector store. You need, like, sometimes it's like an all caps situation where it's like you must retrieve the relevant context from the vector store. You need to do it. This is how you do it.
Yeah, I think that's a great answer. And I just to build on that, yes, and one of my coworkers taught me that one. Yes, and I think that like whenever you're thinking about this, you need to think about your audience, right? So how is the audience going to prompt the LLM, right? If you know how the audience of this AI agent is going to prompt the LLM, then in the description you can target the prompt directly. And so what I'm thinking is, like, for example, in the description, you can put something like, use this vector store to answer any questions related to, you know, company knowledge, right? Keeping it open. That way you leave an out for, like, if somebody says, what's 3 + 3? You know, that it might use a calculator tool or something else as opposed to the vector store, because it doesn't need it. But when you connect, like, you know, well, you know, how, in the company n8n, how do I do blah, blah, blah? In the company of, that dovetails with the description of company knowledge. Those two things intersect, and all of a sudden the AI agent knows, hey, there is a connection between the query and this vector tool that I have. Let me use this tool to get more context. And then it spits it out. So you have to understand kind of how the request is going to enter in, and then tailor your vector store's description to capture that. Or, like in your case, kind of brute force it, where use this for everything. Just always use it. Either way will work, but then one could affect cost versus the other.
And the other point on that is also, you want to put in the tool description, if nothing relevant can be retrieved, then say that. Don't make up you know, use the vector store, but do not make up an answer for it at any cost. So yeah, and like, as to what you're saying, you can add like somewhat limited guardrails and instruction and detailed instructions in the system prompt, the tools description, all of that stuff too. And with that, you do want to keep in mind, like, what is the user what's the end user's goal, and how are the different ways that
they might require. Yeah, good call. I see here, what is the right place to prompt for tools description? One thing I've been doing wrong recently, that I only recently fixed in n8n, is that I've been hard coding the tool names and the tool descriptions inside of the agent's, like, system message, right? What you can do instead is put the bracket squiggly, the word, I think, tools or tool, and then close bracket squiggly, and that will automatically replace it for the AI agent with a list of all the tool names and descriptions. So you can actually do that to inject into your prompt and like a dynamic listing of the tool name and the prompt, so that, but all you have to do is put that kind of tools variable, and then within it, it'll automatically expand when it runs the query to all those tools in the description. So what I've been doing is using that as a way to, anything that's connected to the tools, instead of like hard coding my tool prompt and description in the system message, I put it in the title of the tool name, and I put it in the description of the tool name, or in the vector store name and description of the vector store. But regardless, just kind of making sure that those are, you know, connected. Vector store is a little different because I don't think it'll show up as a tool, if I'm not mistaken. I have to double check, but just something to kind of keep in mind. All right, let's take a look here. We're almost there, folks. I'm going to answer just a few more, and then I'll let poor Mary go here. I appreciate your patience, Mary. Let me choose a new one here. Let's see. We've already kind of answered this, but why did you choose Weaviate instead of Supabase that could be free for a while? Now, I know that you've worked at Weaviate. Can you tell me a few reasons why you might want to use Weaviate as opposed to something like Supabase, which has like more of a free tier?
Yeah, so you can definitely use Weaviate locally if you don't want to pay like for Weaviate Cloud, but they also have a pretty generous, they call it like a sandbox. So basically you get a free cloud cluster for about 14 days, I think, and then you can extend the life of that 2 times, maybe 3 times. And so for me, that was just the easiest way to do it. Also, when I worked there, I got free clusters as well.
Yeah.
Yeah, not anymore, but yeah, they have a pretty generous free trial, and but yeah, you can use any vector store you want, really.
I love it. I love it. We have a lot more. One last one. It's not a question, but I thought it was interesting. I haven't checked this out yet, but Jen Kixer mentioned this new Strawberry browser is a great example of I can't pronounce it now, agents for the users. I'm gonna have to check that out. It sounds interesting. So I did find that.
Yeah, I'm on the website right now.
I'll have to check it out. Wonderful. Mary, this has been such a pleasure. I hope we do this again. Now,
Me
could
too.
do you have any links, anything that we can promote as far as if people want to get a hold of you, want to find you, want to hire you? Because I hear that you're working for yourself now. Is that correct?
Yeah. I'm doing very deep dive technical content creation specifically for AI startups.
Mhm.
So doing things like this webinar, blog posts, social media strategy, gated content, stuff like that. And so you can check out my personal website at newhauser.dev. That
Mhm.
should be linked to in the Luma event page. You can also find me on LinkedIn. I'm happy to connect, happy to answer any questions that you might have on the webinar. And I sent out a link for the slide deck for this presentation. And maybe we can put that, I don't know, Angel, we can figure out maybe where to put that so that people have access to the slides as well.
Yeah, for sure. And I put it there on the screen so people can, that are
Thank
watching
you.
see it. So yeah, for sure. And I was worried about audio issues, so I did link a Descript link in our chat. That link will probably stop working after this, and I will be fixing our YouTube version so that it's easy to access and view and whatever. But otherwise, this has been a pleasure. Hope to do this again. If you'd like to find more information about Mary, check out our website there at the bottom of the screen. Otherwise, thank you all for attending. Can't wait to do this again, and I hope you have a wonderful day. Take care,
Thanks, everyone. Bye, Angel.
Bye, Mary. Take care.